Trigonometry. Trigonometry is derived from two Greek words, that is trigonon and metron, and this means measurement of triangles. So we are going to draw some triangles, measure them, then we'll establish some relationship or observe some patterns. We are going to restrict our measurement to right-angled triangles for now. So kindly take your piece of paper or notebook and draw a right-angled triangle. So this is mine. We need to obtain similar triangles so that we can get consistent results. So we divide this triangle into as many similar triangles you can. Divide your triangle into as many similar triangles you can. For the time being, I'll divide mine to only 3 similar triangles. So the measurement is going to be that of an angle and that of the size. So this is our first triangle. Let's measure the angle over here first. So this is approximately 53. 1, 2, 3. So 53.13 degrees. So we've gotten our angle to be 53.13 degrees. Yours might differ. Then now let's measure the size. So each box is 1 unit. So this is 1, 2, 3. So this is 3 centimeters. Then we measure this side 1, 2, 3, 4. So this is 4 centimeters. Now let's write down the ratio opposite over hypotenuse. So we can repeat the same thing for yours also. So the opposite to this angle is the 4, and the hypotenuse we don't know yet, but from Pythagoras theorem we can find the hypotenuse. You can also measure yours, but from Pythagoras theorem the measure of mine will be 5 centimeters. So over here we obtain the ratio opposite is 4 and the hypotenuse is 5. So this will give us 4 over 5. Now the adjacent over the hypotenuse, adjacent is 3. So you are going to get 3 over 5. Then the opposite over the adjacent will give us 4 over 3. Now let's do for that of triangle 2. So the angle itself the same, 53.13 degrees. So this side, the adjacent side will now be 1, 2, 3, 4, 5, 6. So this is 6 centimeters now. Then this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 centimeters now. Then this side will now be equal to 10 centimeters. So you can also measure the size of your right angle triangle. Then now let's take the ratio opposite over hypotenuse will give us 8 over 10, and this will simplify to 4 over 5. Now adjacent of hypotenuse will be 6 6 over 10, and this will simplify to 3 over 5. Then now the adjacent, the opposite over adjacent will be 8 over 6, and this will simplify to 4 over 3. Then for this triangle, the angle is still the same, so we have the measure of this side to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 centimeters over here, and this is 12 centimeters. So this will be 15 centimeters. Now we take the ratio again, opposite of hypotenuse. So this is the angle, the opposite is 12 centimeters over the hypotenuse, which is 15, and this will still simplify to 4 over 5. Then also this will give us adjacent is 6 over the hypotenuse 15, and this will simplify to 3 over 5. Then we have 12 over 9, and this will simplify to 4 over 3. So we can see that for all the ratios, the values are constant despite different sizes of the triangle. That constant ratio is what we call the sine of the angle theta. I would like you to take your calculator and find the sine of 53.13 degrees. You see that it will be approximately equal to 4 over 5, if correct to 2 decimal places. Then also this constant ratio is called the cosine of the angle. The cosine of the angle. So let's say it equals 53.13. Yours might be different, your angle might be different, but you should get a constant ratio for this. And that constant ratio is what we call the cosine of the angle. Then so you can find cosine of 53.13, and it's supposed to be correct. It's supposed to be correct to 3 over 5 to 2 decimal places. Then also this constant ratio is called the tangent of 53.13 degrees. So we have measured our angles in degrees. There are other units of measurements like the radians, but we are going to deal with the degrees for now. So you can also find a tangent of 53.13, and you see that it is approximately equal to 4 over 3, correct to 2 decimal places. So far we have seen that the sine of an angle of a right angle triangle is equal to the opposite over the hypotenuse. Then the cosine of an angle is equal to the adjacent over the hypotenuse. Then the tangent of an angle is equal to the opposite over the adjacent. So we use the acronym. So car tour to remember the relationship between the sides in relation to the angle. You must commit these mnemonics to your memory because it can help you in our subsequent lessons. Special angles. There are some angles that we need to know their trig ratios. We use diagrams to derive these angles. So we are going to start with the square. We all know what the square is. It has all the sides equal. That is one of the properties of a square. So if this is L units, then this is also L units. Now let us connect one of the diagonals of the square. Then we know that the square is also having this right angle over here and here. So this is also right angle, this is right angle. Then from Pythagoras theorem, we can find the hypotenuse. This is not the hypotenuse. So the hypotenuse is identified by drawing an arrow away from the right angle. This is the hypotenuse. Then we find this length. So let this be the hypotenuse, let's say h. So we know that h squared will be equal to L squared plus L squared. So this will be equal to 2L squared. So we have h squared is equal to 2L squared. Now take the positive square root of both sides to obtain the h to be equal to square root of 2L squared. And this will give us root 2L root 2L. So this side is equal to root 2L or L root 2. This angle is a 45 degrees angle because the diagonal will bisect the 90 degrees to give us 45 degrees over here. So this is also 45 degrees. So we are going to use one of them. Now we start with the cosine of this angle. So the cosine of the 45 degrees angle, we know that the cosine ratio is equal to opposite over adjacent over the hypotenuse. Now the adjacent is equal to L and the hypotenuse is equal to root 2L. So this will cancel this. So we obtain 1 over root 2. And we rationalize this to obtain cos 45 degrees to be equal to root 2 over 2. So cos 45 degrees is root 2 over 2. Then let's find the sine. So sine is opposite over hypotenuse. So sine 45 degrees will be equal to the opposite is L. So L over the adjacent is the hypotenuse is root 2L. So we simplify to also obtain root 2 over 2. So cos 45 sin 45 is also equal to root 2 over 2. Now to find tan 45, we can either use the sine and the cosine to find tan 45. Because tan is equal to sine over cos. So which will be root 2 over 2, which will give us 1. Or better still, we can use tan 45 from the diagram. We can find tan 45 degrees to be equal to opposite over adjacent, which is L over L, and this will give us 1. So tan 45 degrees is equal to 1. So this is our first set of special angles. Now, our next set of special angle is the 0 degrees. 0 degrees. As at now, this angle is 45 degrees. Now, how can we get 0 degrees from here? We can get 0 degrees only when the hypotenuse has dropped to the adjacent. So that is when this angle is 0, then the hypotenuse will fall on the adjacent side. So we can say that the angle is now reducing. This is no longer 45, it's less than 45, that's approximately 19. So we realize that the opposite side to this angle too has also reduced. So it's also vanishing. So it has now vanished. So right now the opposite side is equal to 0. So opposite side will be equal to 0. That is the 0 degrees. If this angle is 0 degrees, then the opposite side is equal to 0. Then the adjacent side will be equal to L. Adjacent side will be equal to L. Then the hypotenuse has now also fallen on the adjacent side, so they are equal. So the hypotenuse will also be equal to L. So now our cos 0 degrees, cos 0 degrees will be equal to adjacent, which is L, over hypotenuse, which is L, and this will give us 1. So cos 0 degrees is equal to 1. Then sin 0 degrees will be equal to opposite, which is 0, over the adjacent, over the hypotenuse, which is L, and this will give us 0. So sin 0 degrees is 0. Then we find tan 0 degrees. So tan 0 degrees will be equal to opposite over adjacent, which is 0 over L, and this will also give us 0. So we will also use the fact that tan 0 degrees is equal to sin 0 degrees over cos 0 degrees to also obtain 0. Now the 90 degrees angle. For the 90 degree angle, we have to use the relation sin 90 minus theta degrees. Sin 90 minus theta degrees is equal to cos theta degrees. Or the other way around. So we want to find 90. To get sine 90, then theta must be equal to 0. So we obtain sine 90 degrees, and sine 90 minus 0 degrees will be equal to cos 0 degrees. Now we know cos 0 degrees will be equal to 1, and sine 90 will therefore be equal to 1. So sine 90 degrees is equal to 1. Then also, to find cos 90 degrees, we know that we use the relation cos, or to find cos 90 degrees, then theta is equal to 90. So theta equal 90, you put it here, put it into this relation. Now we want to find sine, we want to find cos 90 degrees. So to get cos 90 degrees, we have to put theta to be equal to 90. So we put theta equal 90 over here to get sine 90 degrees, sine 90 minus theta, that is 90, sine 90 minus 90 will be equal to cos 90 degrees. So sine 90 minus 90 will give us sine 0 degrees equal cos 90 degrees. So cos 90 degrees, we know that sine 90 degrees, sine 0 degrees will give us 0. Hence, cos 90 will be equal to, cos 90 degrees to be equal to 0. Now we find tan 90. So to find tan 90, you know that tan 90 degrees will be equal to sine 90 degrees over cos 90 degrees. And this will give us 1 over 0, and 1 over 0 is not defined. So it's undefined. It's undefined. So tan 90 is not defined. Now we need to find 60-degree angle. Here is an equilateral triangle. So first we use the square. This time we use the equilateral triangle. So we know that all the sides of the equilateral triangle are the same. So this must be L. So this will be half L, and this one will be half L. Then this will bisect this angle. So this angle will be 30 degrees, and this angle will still be 60 degrees, because we know that each of the angles of an equilateral triangle is 60 degrees. So now we find cos 60 degrees. But before that, we need to find this length from Pythagoras theorem. We know that let this one be the height h. So the height, that is the length squared, hypotenuse squared, will be equal to the height squared plus length over 2 all squared. So this will be equal to, we are looking for the height squared, so we make that a subject. The height squared will be equal to the length squared minus the length squared over 4. So this will give us 4L squared minus L squared over 4. So we have the height squared to be equal to 3L squared over 4. 3L squared over 4. So now our height will be equal to the square root of this, which will give us 3 root 3 will give us root 3L over 2. So this side is equal to root 3 over 2L. So cos 60 will be equal to cos 60 degrees will be equal to opposite. Adjacent is L over 2 over the hypotenuse, which is L. So this will simplify to 1 over 2. So we find cos 60 to be equal to 1 over 2. Then sin 60 will now be equal to opposite, which is equal to root 3 over 2L over the hypotenuse, which is L. And this will cancel this to give us root 3 over 2. So sin 60 is root 3 over 2. Then we find tan 60. Tan 60 will be equal to root 3 over 2 L over 1 over L over 2. So root 3 over 2 L over L over 2. So this will give us, this will cancel this also cancel this. So we are left with root 3. So tan 60 is equal to root 3. Now I'm giving this to you as an exercise. Do it and obtain the following results. Tan 30 degrees, cos 30 degrees is equal to root 3 over L over 2. Then sin 30 degrees is equal to 1 over 2. Then tan 30 degrees is equal to root 3 over 3. So these are the special angles that you have to commit into memory, because you'll be examined on them. Reciprocals of the trig ratios. You've seen the three ratios: cosine theta, sine theta, and the tangent of theta, to bear the following ratios. Now the reciprocals of this ratio, say hypotenuse over the adjacent is called secant theta, or the secant of the angle. Then the reciprocal of this, which is the hypotenuse over the opposite, is called the cosecant, or for short cosec, of the angle. Then the cotangent is the reciprocal of the tangent. So in other words, cos theta is the reciprocal of sec theta. That is, sec theta is 1 over cos theta, and cos theta is also 1 over sec theta. Then cosec theta is 1 over sin theta, and sin theta is also equal to 1 over cosec theta. And the same thing is true for the cotangent. So if you are asked to find if we have cos theta degrees to be equal to 1/2, then sec theta will be equal to 2/1, which is the same as 2. So given any of the trig ratios, we can express one in terms of the reciprocal. Or if you know the reciprocal, then we can find the basic ratios. Complementary angles. Two angles are said to be complementary if they add up to 90 degrees. Already we know that this angle is 90 degrees. Therefore, these two angles must add up to 90. So if this is theta, then the other one must be 90 minus theta degrees. Now let this side have a unit. Let this side be a unit. Then this be b unit. And this is c unit. Then we know that sine theta will be equal to the ratio of opposite, which is a over c. Then cos theta will be equal to the ratio of adjacent over hypotenuse, which is b over c. Then let's find the same ratios for the complement. So we have sine 90 minus theta, they are in degrees. Degrees will be equal to opposite, which is b over c. Then cos 90 minus theta degrees will be equal to adjacent, which is a over c. So from this, we can conclude that a over c is equal to a over c. That is sine theta, sine of an angle theta. If the two angles are complementary, then sine theta will be equal to the cosine of the complement of the given angle, which is 90 minus theta degrees. Then cos theta is also equal to the sine of the complement of the given angle. So 90 minus theta degrees. So for instance, if you have sine 40 degrees, then it should be equal to cos 90 minus 40, which is 50 degrees. Then also sine 30 degrees should be equal to cos 60 degrees. Now let's do some practice with the special angles. So we have sine 60, which is the same as root 3 over 2 plus tan 45, which is the same as 1 all over sine 45, which is root 2 over 2, then plus tan 60, which is root 3. This will be equal to, we collect the LCM, 2, then 2 goes here 1, so we get root 3 over here, then plus 1 goes into 2 times 1, we get 2, then over LCM over here again, we get 2, then 2 into 2, 1 times 2, we get root 2, then 1 into 2, we get 2 times root 3. So we get plus 2 root 3. Now the next stage is to reciprocate this. So we get root 3 plus 2, root 3 plus 2 over 2 times 2 over root 2 plus 2 root 3. So we continue. We don't leave it like this. So we simplify this to obtain root 3 plus 2 all over root 2 plus 2 root 3. Now we don't leave the set in the denominator. So we rationalize it to obtain the conjugate of this is root 3 minus 2 root 3. So we get times root 2 minus 2 root 3. The conjugate is root 2 minus 2 root 3. Then we have root 2 minus 2 root 3 over here. So this gives us root 3 times root 2 will give us root 6. Then root 3 times this will give us negative 2 times 3. Root 3 times root 3 will give us 3. Then we also have 2 times root 2 we get plus 2 root 2. Then we have 2 times minus root 2 we get minus 4 root 3. Minus 4 root 3. So all over. Now this and this will give us 2. Then this and this will give us minus 6 minus 2 root 6 minus 2 root 6 over here. Then this and this will give us plus 2 root 6. Then we have this times this will give us minus 4 times 3. So we simplify this to obtain root 6. Then this will give us minus 6. Then we have plus 2 root 2 minus 4 root 3. All over 2 minus 12. So this and this will give us 0. So we simplify further to obtain root 6 minus 6 plus 2 root 2 minus, there's a 4 here, minus 4 root 3. So minus 4 root 3 over here. All over negative 10. So this is the same as 1 over 10. 1 over 10 times 4 root 3. 4 root 3 plus 6. Then minus 2 root 2 minus root 6. It is now your turn to also practice, and you should get this as your final result. So we have sine 30, which is 1 over 2 plus tan 30, which is root 3 over 2, root 3 over 3. then over cos 30, which is root 3 over 2. Now we simplify to obtain, we have the LCM to be 6, so we get 3 plus 2 root 3 over here, then all over root 3 over 2. So this will go here 3 times, so this will simplify to 3 plus 2 root 3 over 3 divided by root 3. That is root 3 over 1. So we reciprocate to get 3 plus 2 root 3 all over 3 times 1 over root 3. 1 over root 3. So this will give us 3 plus 2 root 3 all over 3 root 3. So we rationalize to obtain, so we multiply by root 3, then by root 3. So we now obtain 3 root 3 this and this will give us plus 6 all over this and this will give us plus this and this will give us 9. So this will simplify to, it's a common factor of 3, 2 plus root 3 over 3. Now it is your turn to also practice, and you should obtain this as your final answer. We are finding the value of alpha and theta. So for the alpha, we were given the opposite to be equal to 4 centimeters, and we're also given the hypotenuse to be equal to 8 centimeters. So now we choose the trig ratio that contains the opposite and the hypotenuse. That is so. So we have sine alpha to be equal to the opposite, which is 4 centimeters, over the hypotenuse, which is 8 centimeters. So we have sine alpha to be equal to 1 over 2. So it means which angle do we take the sine of to get 1 over 2? If you send your mind back to special angles, you know that that angle is 30 degrees. But we can use the calculator to find the sine inverse of 1 over 2 to be equal to 30 degrees. So you can take a calculator, press shift to sine, then to give the sine inverse function, then type 1 over 2 in the argument, then to give you 30 degrees as the answer. Now for the theta degrees angle, we're given the adjacent to this angle, which is 4 centimeters. Then we're also given a hypotenuse. So the hypotenuse is equal to 12 centimeters. Therefore, we choose the trig ratio K, that is cos theta will be equal to adjacent, which is 4 centimeters, over hypotenuse, which is 12 centimeters. So this will give us 1 over 3. So we have cos theta is equal to 1 over 3. So theta will be equal to the cos inverse of 1 over 3, and this will be equal to 70.53 to 2 decimal places. Now this is your turn. You try this one, and you should obtain this as your answer, correct to 2 significant figures. You are finding the value of x and y in the diagram. So for the 55 degrees angle, we have the hypotenuse and the adjacent. So we use cos. The cosine of 55 degrees will be equal to adjacent, which is 4 centimeters over x centimeters. So now we make x the subject to obtain x to be equal to 4 divided by cos 55 degrees. So x will be equal to 6.974. So to the nearest whole number, x will be equal to 7 centimeters. Now for y, we have the adjacent and the opposite given. So we use tan. So tan 64 degrees will be equal to opposite, which is 12 centimeters, over y centimeters. So we make y the subject. Y will now be equal to 12 over tan 64. Measuring in degrees. So 12 divided by tan 64. So y will be equal to 5.85, which is equal to 6 centimeters to the nearest whole number. So this is for you, and this is the results that you should get to the nearest whole number. So this is an isosceles triangle, and we know that this will give us 32.5 degrees. Only this angle gives us 32.5 degrees. So we know one angle, and we are asked to find the hypotenuse. This is 90 degrees to this. This line bisects this, so this must be 6 centimeters. We know an angle and the side opposite to it. We are asked to find the hypotenuse. So we use a trig ratio that involves opposites and the hypotenuse. So that is sine. So we have sine 32.5. Sine 32.5 degrees will be equal to the opposite, which is 6, over the adjacent, over the hypotenuse, which is x centimeters. So we make x the subject to obtain 6 over sine 32.5. So we have x now to be equal to 11.167. So to 2 significant figures, we'll get x to be equal to 11 centimeters. Then we are asked to find y also. So for y, we can still use this, or we can still use this. So for y, we know that tan 32.5 tan 32.5 will be equal to opposite, which is 6 over the adjacent, which is y, that we don't know. So y will now be equal to 6 divided by tan 32.5 degrees. This will give us y to be equal to 9.42. Then to the nearest, or to two significant figures, this will give us 9.4 centimeters. Now this is your turn, and you should obtain this result if you work correctly. We're given cos x equal 1 over 2, where x is an acute angle, and we are asked to find the value of sin x, tan x, and sec x. To solve this kind of question, we need to illustrate the ratio on a right angle triangle. So this is a right angle triangle. Now we identify the acute angle. Let's say this is x. Someone can place it here to get the same result. So if this is x, then our adjacent side is 1, the hypotenuse is 2. Now we find the opposite. So let the opposite be y, then we must have y squared plus 1 squared is equal to 2 squared. So y squared will be equal to 4 minus 1. So y will be equal to the positive square root of 3. So this is root 3 units. Then we are asked to find the value of sin x. We know sin x is given by opposite, which is y, so root 3 over hypotenuse, which is 2. Then tan x is given by opposite, which is root 3 over adjacent, which is 1. So tan x is equal to root 3. So the c part, sec x is equal to 1 over cos x. So this will give us 1 over 2, and this will give us 2. I try this one, and you get the following results. So x is an acute angle, and we are finding the value of this expression and this expression, then finally x. So if we have this expression, then we can only divide both sides by the multiplier, which is 2. This is an angle, so we can divide through by this. It's called an argument. We can only divide through by this. So we have over 2, then over 2 over here. So now we have cos 3 into bracket x minus 15 is equal to root 2 over 2. So we need to represent this. Consider this whole thing as an angle. So represent this on a right angle triangle. So the whole angle is 3 into bracket x minus 15. That's the whole angle. Then the adjacent to this angle is root 2. And the hypotenuse is 2. So we represent the opposite with y. Then we must have y squared plus root 2 squared to be equal to 2 squared. So we must have y squared to be equal to 4 minus 2. So y is equal to the positive square root of 2. It should give us root 2 units. So this is root 2 units. Then we now find sine 3 into bracket x minus 15. Now this is the angle. The opposite is root 2. The opposite is y. And y is root 2 over 2. Then we find tan. So this is the A aspect. Then the B aspect. We find tan 3 into bracket x minus 15. So this will be equal to opposite, which is root 2, over adjacent, which is root 2. So tan 3 into bracket x minus 15 will now be equal to 1. So the C aspect, we are finding x. We can use this or this. So we take the tan inverse of this to obtain 3 into bracket x minus 15 is equal to the tan inverse of 1. So this will give us 3 into x minus 15 is equal to 45 degrees. So we must have, dividing both sides by 3, we get x minus 15 to be equal to 15. Hence, x is equal to 30 degrees. So we have tan theta is equal to 2, which will be same as 2 over 1. So if this is our theta, then this is our opposite, and this is our adjacent. Then we can use Pythagoras theorem to find the hypotenuse to be 3 units. So this will now be equal to 1 minus 2 times sine theta. Sine theta is opposite over hypotenuse, which is 2 over 3, 2 over root 3, all over 1 plus sine theta, which is 2 over root 3. Now we simplify further to obtain root 3 minus 4 over root 3, then all over root 3 plus 2 over root 3. Now when we reciprocate this, the root 3's will cancel. So now this will cancel this. Then we'll have root 3 minus 4 over root 3 plus 2. Now we can rationalize this to obtain root 3 minus 2 over root 3 minus 2. So now root 3 times root 3 will give us 3. Then this and this will give us minus 2 root 3. This will give us minus 4 root 3. Then this and this will give us plus 8. Then over this will give us 3 minus 2 squared, which is 4. So we simplify further to obtain 11 minus, this is 4 root 3. So 11 minus 6 root 3. All over negative 1. So this will give us 6 root 3 minus 11. Now this is your 10. And you should obtain x to be equal to 15 degrees. So we are solving the equation tan square theta over 3 minus 1 is equal to 0. So we group like terms to obtain tan squared theta over 3 is equal to 1. Then we create a fraction to obtain tan squared theta is equal to 3. Now the set theta is an acute angle, so we take the positive square root to obtain tan theta is equal to the positive square root of 3. So theta will be equal to the tan inverse of root 3. And this will give us theta to be equal to 60 degrees. So we have 5 sine 5x is equal to cos 20 degrees. Now we can make use of the complementary angles. So we know that cos 20 degrees is supposed to be equal to, from the complementary angles, we know cos 20 degrees is supposed to be equal to sine 90 minus 20 is sine 70 degrees. So whenever we see cos 20, we can put sine 70, and we obtain sine 5x is equal to sine 70 degrees. Now the arguments are the same, so you equate them. So you must have 5x to be equal to 70 degrees. So divide through by 5, we obtain x to be equal to 14 degrees. Or we can use the calculator for it over here and take the sine inverse of the result. You obtain the same answer. Angle of elevation and depression. Let's say you are peeping through your window on the second floor. This is your normal eye level. If there's something that you want to look at the top of this tray, then you raise your head at an angle. That is what we call the angle of elevation. Then if the thing is below your eye level, then you have to move your head downwards to look at it. And that is what we call the angle of depression, the angle that it makes with the normal eye level. The angle of elevation of the top of a ladder from a point on a horizontal ground 36.3 meters away from the foot of the ladder is 42 degrees. We are finding the height of the ladder. So let this be the ladder, then 36 meters away. So this is 36.3 meters away. Then so from this point, you raise your head to spot the top of the ladder at an angle of 42 degrees. So we want to find the height of the ladder. So this is involving tan. So we have tan 42 degrees. Tan 42 will be equal to opposite, which is h, over adjacent, which is 36.3 meters. So h meters over 36.3 meters. So we are tan. So we make h the subject. To obtain h is equal to 36.3 times tan 42 degrees. This will give us 32.68 to 2 decimal places. From a point 65 meters above the ground. So let this be the point. Then a point is sighted on the ground at a distance. So you are from here, you are here, no, you are here, and you sighted a point over here, and that is 239 meters away. 239 meters away. So there's an angle that is created over here. That's the angle of depression. So let that angle be theta. Then it must be equal to this angle by the alternate angles property. Now the height of this is 65 meters. So we are asked to calculate the angle of depression. So this involves tan. So we take the tangent of the angle theta. So tan theta should be equal to opposite, which is 65 over 239. So theta will be equal to the tan inverse of 65 over 239. And this is equal to, is approximately 15 degrees. That's the nearest degree. George stands 70 meters from the base of a building. So let this be the building. Then 70 meters from the base, so is 70 meters away. Then Jenny is also 40 meters away. Then the angle of elevation of George is 35 degrees. Then that of Jenny we don't know, so let it be theta. Now we are asked to calculate the height of the building. So this also involves the tangent ratio. So we have tan 35 degrees will be equal to the opposite, which is h over 70. So h will now be equal to 70 times tan 35 degrees. And this is equal to 49.01 to 2 decimal places. Now the second part is we should calculate the angle of elevation of the top of the building that Jenny would measure. So that is theta. So this also involves the tangent ratio. So we have tan theta is supposed to be equal to the opposite, which is h, and h is 49.01 over this actually meters, not degrees. So 49.01 over 40 meters. So theta will be equal to the tan inverse of 49.01 over 40, and this is approximately equal to 51 degrees. A man is 2.4 meters tall, so let this be the height of the man, 2.4 meters. Then the man is 10 meters away from the building or from a tree, so this is the tree with 16 meters high. Then the distance from the tree is 10 meters. So we are calculating the angle of elevation from this point. So let that angle be theta. Now we need to find this height. We know this length to be 10 meters because this is a rectangle. Then this is already 2.4. So 16 minus 2.4 will give us 13.6. 13.6. So that will be the distance from here to here. Now tan theta will be equal to 13.6 over 10. So theta will be equal to the tan inverse of 1.36. So this will give us 53.67 degrees. That's the 2 decimal places. The length of the shadow of a pole. So let this be the pole. Then the shadow was here at first. Then it increases by 48 meters. So the distance between the first point and the second point is 48. Now, the nearer shadow will have the biggest angle of elevation. So this is 62 degrees and this is 48 degrees. Now we are asked to calculate the height. So we don't know this length, so we represent it with a variable, let's say x. So using the first triangle, we have tan 62 to be equal to h over x. Now we are looking for the height, so it will be faster if we eliminate x. So x will be equal to h over tan 62 h over tan 62. So let this be our equation 1. Then also we have the tangent of the 48 degrees angle to be equal to h over the adjacent is from here to here, so it is 48 plus x meters. 48 plus x meters. So now we work for h. So we have 48 plus x times tan 48 is equal to h. Now we substitute x over here to obtain okay, now let's expand to obtain tan 48, that is 48 times tan 48. 48 tan 48 plus x tan 48 is equal to h. Now let's substitute the value of x over here. So we obtain 48 tan 48 to be equal to, now that is plus x, which is h over tan 62 tan 48 is equal to h. Now we make h the subject, but first of all we need to create this fraction. So we multiply through by tan 62. So we have 48 tan 62 times tan 48 plus h tan 48 is equal to h tan 62. So now we group like terms. So we have h outside, then tan 62 minus tan 48 is equal to 48 tan 48 tan 62. So we divide both sides to obtain h is equal to 48 tan 48 tan 62 all over tan 62 minus tan 48. And this will give us 130 meters. That is 130 to the nearest whole number. And our last example, from 2 points P and Q. So let this be the pole. Then we assume that they are on opposite side at first. So let this be P, then let this be Q. Now let this be P and this be Q. So we are told that one of the angles is 30 degrees and the other one is 60 degrees. The nearest is having a higher angle of elevation, and they are 4 to 3 meters apart. So 4 root 3 meters apart. So now we are looking for the height of the building again. So the height of the pole. So we use a tangent ratio again. So we have tan. Now we need to find this distance that we don't know. But we know that the two distance will give us 4 root 3. So let this be x meters. Then from here to here will be 4 root 3 minus x. So that will be the distance from here to here. Then here to here is what? X. So we have tan 30 to be equal to h over 4 root 3 minus x. Now we know that tan 30 is root 3. So we know that tan 30 is root 3 over 3. So we have root 3 over 3 times 4 root 3 minus x is equal to h. So this will give us 4. This will give us 4 minus x root 3 over 3. Is equal to h. So let this be our equation 1. Then now from the smaller triangle also we have tan 60 is equal to h over x. So we have our x to be equal to h over tan 60. And we know that tan 60 is root 3. So now we substitute the equation 2 into the equation 1 to obtain 4 minus x. Now the x is h over root 3. Then times root 3 over 3. Times root 3 over 3. So this is actually multiplying this. Then it's equal to h. So we have this, cancel this. So we have 4 minus h over 3 is equal to h. So we now solve for h. We group like terms to obtain 4 is equal to h plus h over 3. And this will give us 4 is equal to 4h over 3. So this will give us h is equal to 3. So the height of the pole is 3 meters. Then the B part, when the points are on the same side of the pole, so we get something like this. Now the distance between the shadow, distance between the points is 4 root 3. So this is 60 and this is 30. So this is h. So we are looking for h again. And we don't know this, so let it be x. So now we use the tangent ratio again. So we know tan 60 will be equal to h over x. That is, our x will now still be equal to h over root 3. So equation 1. Then we are also looking for, now we use the bigger triangle. So from here to here will be 4 root x plus 3. So we have tan 30 is equal to h over 4 root 3 plus x. So we know that this is root 3 over 3. So we have root 3 over 3. Root 3 over 3 times 4 root 3 plus x is equal to 8. So this will give us 4 plus x. Okay, 4 plus x root 3 4 plus x root 3 over 3 is equal to 8. So we substitute the value of x over here to obtain 4 plus the x is 8 over root 3. So 8 over root 3 times root 3 over 3 is equal to 8. So now we get 4. This will cancel this. 4 plus 8 over 3 is equal to 8. Now we solve for 8. So we have 8 minus 8 over 3 is equal to 4. So we have 2 over 3 8 is equal to 4. So we get 8 is equal to 6 as the result.